So far we had seen the equivalent resistance by using network reduction method. What is network reduction method? Is that if two elements are connected in series, we replace those two elements by its equivalent resistance. In other way, if two are found to be connected in parallel, then we replace those two parallel connected resistors by its equivalent value. We know how much is the equivalent in series case and in parallel case. But there are some situations while applying that network reduction techniques, sometimes we may found the elements of the circuit are neither series nor parallel. Then in that situations we are in a confusion state how to get that corresponding network into single equivalent resistance value. So this star or delta kind of configurations will be identified. Then once we transform this star or Y connection into delta connection kind of thing, or delta into Y connection, these kind of transformation once we do, then we will come across some elements may be either series or in parallel. So in that point of view we would like to study this star delta transformation. So let us see what is the star or Y, what is the delta, or some other name is there which is pi. So we will see these things. Now see here, so like if I want the equivalent resistance between these A and B terminals, so which is connected across the voltage source, then first what we would like to do is that we will identify some nodes. These are the nodes. This is of course B side. Now here first see that is there any simple node? No. So this node is also connecting one side voltage source and here R5, here R6. However, this B node we should not eliminate it. Don't say that so this side nothing is connected, so R5 and R6 is in series. Don't say like. Why? Because in that process this B node going to be vanished. Then between which terminal are you going to find the resistance means that is a big question. Why? Because B is not there. In the process of R4 and R5 and R6, that B got vanished. So we should not vanish the required terminals. So this must be there, which means that this is not a simple node. That is fine. Next, is there any parallel connected elements in this? Verify. Can I say R2 and R3 is in parallel? If so, then let us verify whether it is really parallel or not. So for which let us assume some node numbers. So where is the R2 connected? R2 one side is connected at N1, other side it is connected at N2. Like this you inspect carefully. What about R3? R3 one side is connected N1, but other side is connected with N3. See that these are not having same common pair of nodes. If this also connected at N2, then we would have say R2 and R3 is in parallel, but it is not connecting at N2, it is connecting at N3. So N2 and N3 is not same, as because R2 and R3 is not having same pair of nodes, we cannot say that these are connected in parallel. In the similar fashion, you try to inspect every element of this by taking some two elements combination whether they are in parallel or not. So you try to see that you cannot find so even single pair of resistors here as parallel or in series also. Then what we need to do in order to get the equivalent resistance between AB terminal? There, so this transformation come into picture. Now try to see, we could able to find some this kind of configurations here. First let me draw those configurations. That is what we call as the T or Y network. That means some resistors you could find in the shape of Y as like this. So does it look like a Y shape? See here. So now can you find something which look like here? So with these characteristics, I will tell you. So initially let me take some nodes N1, N2, or you may get confused with this already existing N1, N2 with that. So instead of that, what I will say is that A, B, C, three nodes A, B, C. Now can I little bit reorganize this circuit in this way? Both are same actually, equivalently same. So this I can equivalently draw just to make this pattern to be in T shape. So I would like to make the same network into this shape also. Now is it look like T? Same nodes, that is what A, B and C, and whose resistors I will try to call with some names. Let us say the wing which is connected to A side node is RA, the element which is connected to B side node is RB, the element which is connected to C side node is RC. And here same where I will come to that point. So let us name that as a small n, small n. So this is a small n and A, B, C is there. So RA, and this is what B and small n is connected with RB, and this is connected with RC. So you can count the small n also, no issue. Small n also there. Now could you see that these two are equivalently same, only shape is different, yes or no? Why? Because between A and N, how much is the resistance here and here? RA. Similarly, you cross verify between B and N, C and N, everything is same. Only shape is little different. So we can say Y network or T network, both are same. Now could you find this kind of nature in the given circuit somewhere? So what is the nature here? Try to identify carefully. Nature here you should understand in this way. So very careful, this is very important point, that you have three nodes. What are they? A, B, C. Next, apart from these three nodes, you will have one extra node which is small n. So totally 4 nodes are there, in which this small n node is common for the three elements. What are they? RA, RB, RC. For these three elements, what is the common node? Small n. And what are its other ends of the elements is RA is connected at A, RB is connected at B, RC is connected at C. With this kind of characteristics, can you find some elements in this network? It doesn't matter what is the shape, whether shape look like exactly Y or T is not matter. But what matters is that three elements must connect, at, I can say in another way also like this here. So three elements are like this. One element is connected to A, one element is connected to B node, other element is connected to C node. These three elements must be joined together at one point. That is what the small n. Could you see this kind of characteristics in the given network? Just try to identify. So, three elements must be connected three different nodes. What are they? A, maybe B, and one more maybe C. These are three different nodes. Try to observe. And what is common for all these three elements is other side which are joined together at some node n. Now can I see here R1, R2, R3. What is the common point for these three? N1. Where R1 is connected? At A. Where R2 is connected? At N2. Where R3 is connected? At N3.
Entry.
Now, could you see this kind of logic here, that A is equivalent to A, B is equivalent to N2, and C is equivalent to N3, and RA is equivalent to R1, RB is equivalent to R2, RC is equivalent to R3. Can I say R1, R2, R3 is connected in Y or star? This we can also call this Y or star. Why? Because it look like star symbol. Y or star or T. Can I say R1, R2, R3 is connected in Y configuration? Got my point? Got my point? Like this, we may find several set of this kind of pattern as like this. R2, R4, R5 is also connected in star. Why? Because R2, R4, R5 is having a common node which is N2. Other end of these resistors are connected at three different nodes. What are they? One is N1, one is N3, one is B. Similarly, can you see R3, R4 and R6 is also connected in star, for which common node is N3, three other different nodes are N1, N2 and B. So, these kind of configurations we call star or Y or T network. Just we are trying to identify what are the network patterns. So, if elements are neither series nor
Sir,
parallel, what kind of combinations we are going to get is one combination is Y network. Yes, tell me, somebody is asking something.
R5, R6 and B are in a Y network, sir.
R5, R6 and
B.
B means B side, is there any element here? Do you have any element?
అంటే Bని కూడా కన్సిడర్ చేయాలన్నారు సార్.
No, 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 not like that. We should consider persons. Persons means elements here. If no element is existing here, how can I say that here some element is there? If there is any resistor here, then you can say that R5, R6 and this element is in star connected. Got my point? As because here no resistance is there, so we cannot say it is in star connected. Okay? Got, got the point? Very good question.
Yes, sir.
Okay. Next, right. So now do you have clear idea that what is the star nature? Nature is three different nodes must be there for the three elements, and these three elements must be connected at one junction which is N. Got the point? Clear? Right. Now let us see not only this kind of configuration, we will find other kind of configuration as like this. The resistors may be connected in this way also. Between three nodes, what are they is some naming, let us say A, B, C. Between three nodes, so three elements may be connected, that is what RA, this is RB, this is RC. So, A side opposite, this is the trick which we usually adapt. A side opposite I will consider as RA, B side opposite is RB, C side opposite is RC. So, opposite in the sense that if you stand over here, what does exactly opposite to you is RA. So, if you stand over here, what does exactly opposite to you is RB, like that. Okay, try to understand, but no strict pattern that you should assume like this only. So, you can assume any name, no issue, but for simplicity and consistent I usually take this kind of thing. Okay. Now, can I make this delta connected pattern into some different way as like this? See here, let me consider here A, here B, A and B nodes are there. These same nodes. Between A and I will consider somewhere here C node. C node. Now what I will do is that, so between A and B one resistance is there. Between A and B one resistance is there. What is that resistance? Is RC. Now from A I will have one resistor and let me connect to the C. That is what? A to C is RB. I will take one more from B and I will try to connect with the C. This is RA. So the same network can be redrawn like this also, which look like pi, as like this pi, which look like pi shape like this kind of pi shape. So we can call delta network as pi network also. So whatever it may be, the naming of it. So what is the characteristics of this delta network? What is the characteristics? Three different nodes. What are they? A, B, C. For example, it is not necessarily A, B, C. Here we are assuming something. Clear? So three different nodes are connected with three elements. Only three elements. Only three elements. Three elements are connected among these three nodes in this fashion. Okay. So if you want more generalized way, you can even think like this. So if this is one terminal, so its other terminal is 1 dash. If this is second terminal, its other terminal is 2 dash. If this is third terminal, its other terminal is 3 dash. What I am doing is that, better to assume in this way, this may be 1, this may be 1 dash. So end terminal of one resistor I am connecting to starting terminal of other. Similarly, end terminal of this resistor I am connecting to starting terminal of other. Like that, end terminal of RC I am connecting to starting terminal. So in this way, we would find some junctions. Those junctions we call as the nodes, and this is what the delta pattern. So now could you find this kind of configuration over here? Between three nodes, three elements must be there. R2, R3, R4 is connected among the three nodes N1, N2, N3, which is delta. If not, other configuration, just neglect this. Other is R4, R5, R6. So there are two delta configuration. Other than this, you could not find. Just check it. Okay. So we will see these kind of configurations in the network circuit analysis. So, but these are the complex situations where we were unable to simplify the network into single equivalent resistance. So what we need to do is that we need to convert one form to another form.
Sir,
Yes, please.
ఒకసారి డెల్టా నెట్వర్క్ లో మనం ఏ నోడ్ దగ్గర బి నోడ్ దగ్గర సప్లై ఇవ్వచ్చా సార్?
Yes, we can give at any node, no issue.
అప్పుడు సి అనేది సింపుల్ నోడ్ అవుతుంది. అప్పుడు
But
ఆర్పి అండ్ ఆర్ఆర్ ఇన్ సిరీస్ కనెక్షన్ అనొచ్చా సార్?
no. Actual in reality, what happens is that this side some other element may connect here. Here some other element may connect. What we were seeing is that, so only these three nodes. Here also some other element may be connected. Here also some other elements may be connected. If not, here other element is not connected, then no question of the delta connection at all. Only if this other element and this other element is connected. But here no other element is, no other segment, means third element is not connected here, means what does it means? Only two elements, no question of delta. Why? Because this is already in series. We will see this kind of situations which comes in various point of view while simplifying it. It try to give you an impression that it is in delta shape, but in reality it may not be in delta shape. That we see. That what you said is that if this is not connected to B, can I say R4, R5, R6 as delta? No, how can you say? Why? Because R5, R6 is clearly with simple node. So this is already in series. Then what is the question of saying that this is in delta? When we say delta or star is that when we go for inspection of delta or star in a circuit is that if elements are found to be neither series nor parallel. If you are already finding some series connection, why are you thinking so much beyond and saying that it is a delta? It is not necessary. Clear? We see in the simplification of the circuits, we see so these kind of things. Okay, you do not worry as of now. I will try to cover those points also. Clear? Clear?
Yes,